welcome to the next series of our classification of the systems. Jai Hind everyone. Let's continue with the last time we leave. So we are talking about the linearity of a systems. Sorry, the uh, systems classified as a linear and non-linear. So as I already told you, the systems that linear systems are those which obeys superposition principle. So if we see that xt is any input given out in a system and we got the output yt, then according to the linearity property that contains the superposition principle, that is the additivity property, which includes the additivity property and the homogeneity property, both, we conclude that a of x1t plus b of x2t will given out a signal, the response a y1t plus b y2t. Okay, so this is what we say that a system is linear. Now for example, let's take an example. For example, suppose xt is given as, sorry, yt is given as cos xt into cos t. Okay, so what happened here, this is a system that is xt into cos t, or better write it as in some other color, that is yt is equals to cos of t into x of t. Okay, now let's start with our system signals processor. It gives out that xt is given into a system, and system, what it did, it multiplied the xt with the cos t, and we get out a yt, that is equals to xt into cos t. Okay, now suppose there is a system x1t, sorry, signal x1t, we give it out in a system, we got y1t. y1t is what? Obviously x1t into cos t. Then we have x2t, suppose this is a into x1t and this is a into y1t, so we got a into x1t. Okay, so we have b into x2t and we give in our system, and this is, we got b into y2t and it is equals to b into x1 x2t into cos t. Now suppose there is x3t which is given into a system. Okay, and x3t is itself equals to a of x1t plus b of x2t, means it's a combination of the above signal, that is equation 1 and equation 2. Okay, and we have given in a system and we got some y3t. Okay, so y3t is what? Something x3t into cos t according to this phenomena. Okay, so this is something we have. Now suppose we have y3 dash t which is equals to the combination of y1t and y2t, that is a of y1t plus b of y2t. Okay, so what is a of y1t? That is a of x1t And what is b of y, a of x1t into cos t, and what is b of y2t, that is b of x2t into cos t. So this is one equation. Suppose this is equation 3, and what we got in a y3t, y3t is equals to x3t into cos t. Now x3t is what? A of x1t plus b of x2t, and it is multiplied by cos t. So we got what? A of x1t cos t plus b of x2t cos t. Okay. Now this equation, the equation 4 and equation 3, are these equal? Since these equation are equal, so we can say that y3t is equals to y3 dash t. That means our system is linear. Okay. So this is the example, this is the how we can say that a system is linear. Now suppose take a very common example of one system, that is the equation of a line, equation of a, in fact, linear line. Okay, let's see that what is the equation of linear line. Yt is equals to, suppose, capital A xt, that is mx plus c. Let's write mx plus c. Yt is equals to m of xt plus c. Now this is the equation of line. Now we already studied in our school 10th standard that this is the equation of linear line. Okay, linear. So we think that it is a linear system. Let's see. Okay, so what given it is that if xt is given in a system, we got, suppose, yt. Okay, and yt is equals to what? M of xt plus c. So now suppose if I given out x1t in a system, what I get in a system, what I get, that is y1t, suppose a of xt, sorry, a of x1t, we got a of y1t. Okay, and it is equals to a into m x1t plus c, sorry, okay, plus c. Understood? Okay, then let's multiply with let's see, it is yeah, then b of x2t given in a system, I got b of y2t, that is equals to b of m x2t plus c. Okay, and suppose I given x3t in a system, and x3t is equals to what? A of x1t plus b of x2t, and if a of sorry, and this is equals to what? It is, sorry, this is got y3t, and y3t is what? M of x3t plus c. Okay, now add something, and x3t is what? M of A x1t plus B x2t plus C. Okay. Now moving to y3 dash t. Y3 dash t is what? A of y1t plus B of y2t. Okay. And it is what? Something like this. That is uh, A of m x1t plus this is A, this is B, plus A of C plus B of m x2t plus B of C, and if it I took it out, m into A of x1t plus B of x2t, okay, this, and plus A of C plus B of C. So this term and this term, it will make y3t not equal to y3 dash t. So it's a non-linear system. System is non-linear. So you see the equation of linear line that we have learned from our childhood, it is a kind of non-linear system. Although the line is linear, but system is non-linear. Okay. Now moving to the next part, that is very important category again, that is time invariant and time variant system. Now what are these systems? Time invariant systems are those systems in which the input output relation does not affected by the time. Means, suppose I have a signal, this is a signal something, okay, suppose it start from, suppose I have a signal, let's take another color, I have a signal, okay, and I have given in a system and we got some output, okay. So the signal start from t is equals to 0, that is the input, start from 2 is equals to 0, the output is also start from t is equals to 0, okay. And if I have delayed, if I start a system with delayed input like t is equals to suppose t naught, okay, then after given inside a system, the output should also start from t is equals to t naught, okay. That means it will not be affected by, the relation will not be affected by the time, uh, because of the time. Suppose whenever I give an input, the output will only be available at that time, okay. So it is something like that. Now uh, let's take an example, it will be more beneficial if we take an example, okay. For example, suppose we have a system like yt is equals to uh, cos t, cos of xt, okay. Let's take a example, yt is equals to yt is equals to, let's take e to the power minus t into xt, okay. Let's take e to the power t, power t. Okay, now what we do, what the time invariancy means, that suppose it is like xt is given inside a system and we get the output, okay, yt, something like that. But the procedure is that suppose xt is given inside a system and we got the yt, and then we delayed our system by t naught, okay, and we got some yt minus t naught here. Or what we do, first we delayed the input, we introduced the delay by t naught, so we got x of t minus t naught here, and then we apply this thing inside our system and we got something yt comma t naught. Now if these two input, that is y of t minus t naught is equals to y of t comma t naught, then system is time invariant. Okay, for example, this system, suppose I have given the xt and it is given in a system, we got yt, and yt is what, e of t x of t, okay, then we given the delay, okay, delay is what, y of t minus t naught, and if we apply, it is equals to y of t minus t naught into x of t minus t naught, okay. Then first we delay by t naught and we got x of t minus t naught, and then we apply to the system, okay, and we got y t dash t naught, and it is equals to, since it is a delayed input, okay, so y of t into x of t minus t naught, because system is what, it is only that we have to multiply it with the a of t. So we have applied the system before, so it is something, what we can say, that it is a time variant system. Okay, so this is a kind of system we have, okay. So this is time variant and invariant system. Now we have invertible and non-invertible system. Invertible and non-invertible system is very easy. Suppose I have some xt and I have square the signal, okay, we got x square t, okay, this is yt, then I have taken the square root of this system, square root of this system, and what we have, we got plus minus of xt, right? So if we obey this, suppose I apply something, I applied some transformation in a system, and if I reverse that transformation, if I got the original input, then the system is invertible. For example, here I have not get the same input, it is plus minus xt and it is only xt, so this is what, this is non-invertible system, non-invertible system. Next, suppose I have given xt and I have delayed by t naught, I got xt minus t naught, then what I've done, I have advanced the system by t naught and I got xt. So this and this is, we got the original signal here, So this is a invertible system. Okay, so this is invertible and non-invertible system. Moving to next part, we have stable and unstable system. Stable and unstable system. What are stable system? Stable system are those for which we have bounded output for the bounded input. For example, if I have a xt that is bounded means xt at limit t tends to infinity should be less than infinite. Okay, so that is a bounded signal. So for the bounded xt, if we have a yt which is also bounded in nature, then this is a stable system. Okay, otherwise we have non-stable system. For example, if yt is equals to e of minus t, okay, and e of minus t, then this is a bounded. Suppose this is xt, and if I apply that we multiply yt is equals to what, a of xt something, so it is e of minus t. Okay, so that is, it is vivo stable system. Or something is that if xt is equals to e of minus t, and what the system do, it will change the negate the signal, then yt is equals to what, e of t, then this is unbounded. This is unbounded in nature, so this is unstable system. Okay, so this is all the classification of the systems. Okay, and moving to next part, if we go for another example of time invariant and variant system. So suppose if yt is equals to cos of xt, suppose I want to check if the system is variant invariant, linear non-linear. Okay, and find out a system is stable or dynamic, causal, non-causal, then what we have, linear non-linear, and time invariant or variant. Okay, so how we proceed? First, yt is equals to cos of xt, that means at t is equals to 0, that is y of 0, I got cos of x of 0. That means it is present and it is present. So the output is depend on the present value of input. That means it is a static. Sorry, this is static. This is a static system. Second part. Move to second part. That is causal non-causal. Again it is static, that means it is a causal. Then moving to next part, that is linear non-linear. That is very important. That is, it is given that xt is given in a system and we got yt, as of cos of xt. Okay, if I have x1t and I have given in a system, then we have y1t, and y1t is what? X of cos of x1t. Okay, then we have x2t, and it is what? Inside a system we got y2t, and it is got x of cos of x2t. Okay, then we have x3t, which is again a combination of x1t plus x2t, and we have applied in a system, we got y3t, that is equals to cos of x3t, that is cos of x1t plus x2t. Okay, and if we add y1t plus y2t, that is equals to y3 dash t, we got cos of x1t plus cos of x2t. Now these two, that is y3t, is not equals to y3 dash t. So this system is non-linear. Non-linear system. So it is a non-linear system. And moving to the next part. Okay, moving to the next part, that is yt is equals to cos of xt. If we say that xt, if we move to first, we pass through a system, we got yt, that is cos of xt, and then we apply a delay by t naught, we got yt minus t naught, that is equals to cos of xt minus t naught, and first we apply a delay of t naught, we got x of t minus t naught, then we apply to the system, and we got yt comma t naught, it is equals to cos of x t minus t naught. Since these two, that is y t minus t naught is equals to y of t minus t naught, then the system is time invariant. So you have to prove this just like that, the system is linear or non-linear, if the system is static or dynamic, or if the system is time invariant or variant. Okay, so thank you so much for the today's lesson.